Where'd you find this?
Welcome to the lesson video for section 1-2, which is all about line segments, finding their measure, and dealing with some missing parts, and also introducing some algebra as well. A line segment is very similar to a line, except that it has two endpoints. You can either have just a segment where it actually ends at those endpoints and doesn't keep going in either direction, or you can just be talking about a portion of a line. You name it very much the same way, either of the two letters from that line segment, and a symbol up on top that is just the line part between the two arrows. No arrows if you're just talking about a segment, because you're talking about a part that stops and doesn't keep going. The segment addition postulate, there's a general formula that looks like this: AB plus BC equals AC. So we're talking about lengths of segments added together here. It works for this type of diagram right here. So we've got a line segment AC with a point B in the middle, 3 points that are collinear, with B between A and C allows us to use this segment addition postulate. Basically, all this is saying is that a part of the line segment plus the other part of the line segment equals the length of the whole thing. So from A to B plus the length from B to C is the same as that whole length from A to C. So that part plus part equals whole general formula that you're looking at here really shows up quite a bit as we move along the semester. So make sure that you keep that in the forefront. So the first example here, so for this example, you've got find the measurement of each specified line segment. So all we're looking at here is first, what's the name of the segment? So we're looking for the length of EG. So based on the part plus part equals whole format, EG is EF plus FG, so 2 plus 5, or 7. Same for B. If we're looking for the length of AC, all we're doing is adding the two parts together. 4.5 plus 3.4, well, that's 7.9. Part C, you've got a missing chunk. You don't know what one of the parts is, but you do know the whole amount. So for this one, all we're doing is subtracting 9.8 minus 6.3, which is 3.5. Okay, the second example, now we're dealing with algebraic expressions. We've got variables in there. So the first step you want to do is label your drawing. So the 5x goes over rs, the 7x goes over st, and we know the whole length of RT is 48. Now using part plus part equals whole, we want to set up an equation. Our two parts are 5x and 7x, and the whole is 48. Now solving this, combine like terms, 5x plus 7x is 12x. Divide 48 by 12 to get x by itself, and you've got 4. Example 3, for this one you don't have a picture, so you need to draw one. It says find the value of A and AB if B is between A and C. So if B is between A and C, you have a line segment with A and C as the endpoints and B somewhere in between them. It tells us that AB is 4A plus 10, BC is 3A minus 5, and AC, the whole length, is 19. So again, part plus part equals whole. So that's how you set up your equation. Part and part. Add them together, equals the whole length. 4a plus 3a is 7a. 10 minus 5 is 5, still equals 19. Subtract 5 from both sides and divide by 7. You'll end up with 2 for your answer there for a. If a is 2, substitute that back in for ab. So 4 times 2, that's 8, plus 10 is 18. Okay, another one, example 4. You're given, I've made it your turn. So do your best to answer example 4, find the value of x and st, and put your answers in the answer blank. All right, another vocab term, congruent segments, are segments that are the same length. In a picture, in a diagram, you use this little hash mark here through the line segments to identify that they're congruent. The symbol for congruent is an equal sign with a little wavy over the top. Example 5, if this whole length is 50 and these two segments are congruent, that means they have to be the same thing. So 50 divided by 2. Each one must be 25. What about a similar thing with algebraic expressions? Again, b is between ac, so your picture looks like that. Then it tells us that AB is 2n minus 10, AC is 18, and it tells us those two segments are congruent, so that means that BC must also be 2n minus 10. Then again, you can do the part plus part equals whole setup and solve. You end up with 9.5 for n. The last problem is your turn. Try to draw it out. Add your labels to the picture, do your best to answer it, and put your answers in the answer blank. We'll talk about it tomorrow.